So through these meetings, SEC members and members of the public have expressed many concerns about the project and about conditions in general in the Delta. Where the input was related to the engineering elements of the project, we've been able to translate a lot of that input into substantial changes in the conceptual designs. So what we're going to do here is go through with you the types of changes and adjustments that have been made over the past 2 years based on either input directly from the SEC or other stakeholder venues, as well as from our own internal design development processes. We're going to group the changes as we go through the slides. We've grouped them into these 10 different categories that we're going to go through, but all of them with the focus of reducing or minimizing local community effects of the project. And then I realize this group has seen a lot of information, engineering information, but it's oftentimes been kind of fragmented. You've seen the designs evolve over time, kind of in bits and pieces. So once we go through these, we'll then do a summary of our quick overview of the current project so that you've got a chance to see what it looks like now and ask any questions or clarifications. Okay, so next slide. So now we're going to go through these. I'm not going to sort of bog down. These, of course, are in your packet and they're available for you to review on your own. But I do want to kind of move through these and just highlight some key items here among those 10 things. So first with the, in terms of avoiding increasing demands for existing emergency facilities or services in the Delta, we have included at the major facilities such as the intakes and the Southern Forebay, Bethany Complex, all of the tunnel launch sites. We have emergency response facilities that would be dedicated to the program, but at the same time, we're totally open to and trying to work with the local emergency responders to see if we can maybe move some of those facilities over to their local locations so that it could help to increase the long-term emergency response capabilities beyond the period of construction. Next slide. So in terms of managing flood risks to the project facilities and existing land uses, all of the conveyance facilities are being designed to the 200-year flood elevation, with including future conditions of sea level rise and climate change. We performed a program-wide evaluation of flood risks and then developed structural and non-structural flood risk mitigations to address those. Some very specific constraints we put on ourselves. We are avoiding the use of levee roads for heavy construction traffic. And we've also established setbacks for any fill placement so that any fill that's being placed as part of the project would be set back from the existing levees to avoid affecting their foundations. We have developed a construction sequence at the intakes that maintains the Sacramento River flood management criteria for the entire duration of construction. And then for all of the southern facilities that would be part of DSOD California Division of Safety of Dams jurisdiction, all of those structures would be designed in compliance and have been conceptually designed in compliance with their requirements. Next slide, please. To manage seismic risks to people and property, we first started out by developing and summarizing seismic design criteria for all the specialized features of the project. Then when we started our fresh siting of all the features and facilities, we considered the presence of existing faults in the region, as well as soil conditions in general, which can affect the seismic response of the facilities. Where it looked like it was needed, we've provided enhanced amounts of ground improvement. So for instance, the intake foundations at the intakes, the Southern Forebay embankments, any of the structures on soft or loose ground all have fully accounted for ground improvement. That's also in the quantities and estimates that are being evaluated in the EIR. And then you're going to see this last one come up. It does affect a number of these different factors, but the use of tunnels to deliver water from the Southern Forebay to the approach channel for the bank's pumping plant is definitely something that is more manageable from a seismic perspective. The alternative would have been a canal system, a surface structure, which would have been much more impactful and be much more susceptible in this case to seismic shaking and movement. Next slide. So in terms of minimizing activities that produce noise, dust, greenhouse gas emissions, traffic, land use, this is a pretty long list that you can see here in these 3 columns. These are all actions that were taken in the conceptual design to try and address some of these issues. Some of them are very specific. I'm looking at, for instance, the very first one, minimizing the impact pile driving at the intakes to really try and reduce noise. Moving over at the bottom of that same column, the fact that we moved the concrete batch plants away from the intakes over to a common location on Lambert, trying to get all of that activity away from the locations around the intakes there. Some of them are more broad. The bottom of the middle column, the fact that we went through and developed a complete program-wide soil balance to try and minimize the amount of extra import or export of fill materials in and out of the project. We even used that exercise to try and optimize the sequence of construction so that all these materials would be available when the time was right to really try and minimize the movements. So there's a whole slew of items here that are listed. I don't want to get too bogged down. One other big one that you may not remember, but on the very right column there, early on we were able to eliminate the intermediate forebay entirely, which would have been a pretty large structure up in Glanville Tract that was part of the old project. Next slide. So in terms of minimizing construction effects to existing infrastructure, other community resources, again, you see that tunnel option from the southern forebay to the approach channel being a factor here as well. We also considered existing infrastructure as we did that fresh facility siting for all of the site elements. We used cutoff walls extensively to minimize the effects of groundwater or the effects of construction on groundwater conditions during construction operations. Committed to capturing, treating, and reusing water generated during construction activities, and then also maintaining the existing irrigation and drainage systems that surround the project sites and areas. Next slide, please. Construction traffic and associated effects, another big one. So we started out first with some big picture constraints. We're limiting routes that would be used for construction traffic. So very limited traffic allowed on State Route 160 and State Route 4. This would really not be heavy construction traffic. Limited activity on Hood Franklin Road, really limited just to buses to shuttle folks from the park and ride lot on Hood Franklin over to the intakes. I mean, even just including the park and ride lots, not only up at Hood Franklin, but at other locations along the project, is intended to really help try and consolidate employee traffic and limit the amount of traffic associated with those facilities. We developed designated access routes and dedicated haul roads for each of the facilities. And that was done using traffic studies, site-specific traffic studies to really understand the traffic impacts of construction. And then also developing rail depots at the bulk transport locations to try and get some of that equipment and material off the roads. Next slide. To minimize disturbance to existing land uses, including ag land, residences, wildlife habitat. Again, the tunnel from the southern forebay to the approach channel impacts the surface, surface effects, as you can imagine. The use of T-screens just shrinks the site footprint up at the intakes. That was an innovation that's new to the project. Also, just that we considered all of the existing structures, the number of parcels, nearby communities, as all part of the facility siting exercise. We've really minimized the amount of nighttime construction activities. We've included plans and provisions for reclamation of agricultural land post-construction to try and get that land back into some sort of productive use. And then again, committing to maintain the irrigation and drainage systems for all the areas that surround the construction sites. Next slide. In terms of minimizing disturbance to sensitive wildlife and protected habitats, we had several strategies to minimize effects of protected areas such as stone lakes and Woodbridge. We shifted facilities kind of all over the place. We moved shafts, we shifted locations to get them out of the flyways or out of the zones altogether. We considered greater sandhill cranes specifically in the siting of facilities and also in laying out power line alignments. We were able to eliminate a tremendous amount of new overhead power line through the efforts of the design team. We rerouted and realigned facilities to avoid wetlands and conservation easements. We really limited the amount of barge use within the total project to try and avoid these effects on sensitive habitats. And then again, that tunnel connection from the forebay to the approach channel, again, has similar effects to the surface habitat. Next slide. So while we're talking about navigation, minimizing effects on Delta water-based recreation navigation. So again, back on barges, we're really limiting the barge use mainly to the construction activities at the intakes. As you heard Phil describe, it's really just for the excavation of soil and placement of riprap. We have no barge landings in the program. Originally, there was a barge landing considered for Bolden Island, but and also for Lower Roberts Island, but there's no barge landings included in the program. And then we reconfigured the Lower Roberts Island shaft site to shift away from the Windmill Cove Marina. And we also, if you recall, the renders that we prepared for the RTM stockpiles, they're tucked now way over next to the existing dredge spoil stockpiles, and they're set to a height limit that doesn't extend above the adjacent fill of the dredge spoils behind them or the levees that surround them. So they're kind of tucked in there. Next slide. And then this is the last one, item 10. So to minimize noise during construction and operations, the use of the cylindrical T-screens really helps with the noise of the screen cleaners. If you remember Phil talking to this group a long time ago about the difference between the screen cleaners of a vertical plate screen versus the cylindrical T-screens, these are noise is virtually non-existent from that activity with the T-screens. We also have accounted for and included noise reduction measures. So we have enclosures like shrouds that you see in the image there for what pile driving is required would be done within a shroud. Also tucking as much equipment as we can inside buildings or inside enclosed structures like the RTM dryers, parts of the batch plant, all of that would be inside structures to try and minimize noise. And again, we've really minimized the nighttime construction activities to a very few critical steps, but overall the general program avoids nighttime construction. So next slide.